start? You guys ready? Are you ready? Okay. This is all about, wait, where am I going here? I've almost forgotten. Right there, estimated weighted total, Excel web page. So what I did is I made this little spreadsheet. Here's all the assignments we've had so far. I estimated how many, I think in class is 20% of our grade. I divided by 10 because I'm just guessing we might have 10. So each one's worth 2 points or 2%. Homework, I guess how many we have, so I put that. Here's our quizzes. This is adding all that together. Here's where you'll place your scores. 87.5, 100, 100, whatever. Place your scores. It will automatically multiply these and do the math here, and it will add it here. And you'll notice this turns into exactly what's in that weighted total column on Blackboard. So what I'm posting this for is if you have this, you can add a column every time we have an assignment and change, make sure the formulas are counting everything. You don't have to do hardly anything else. You'll always know where your grade's at then. So I posted that. Hopefully you'd use it. So so this means that 34% of the assignments have been graded and done. We have 65.7% of the stuff that needs to be graded left to go. Seems like we're farther than that, but we're only like a little over a third of the way through the class, I guess. The final's such a big deal, and it's at the end. So now, we have to feel confident that we can read a story and form a linear programming model. And a linear programming model from this point on is, number one, identify your variables that you need to make decisions. That's number one. Number two is create your objective function. But two, you can switch to three if you want. And three is create your constraints. That is a linear programming model. You're going to see questions from this point on. Create a linear programming model or write a linear programming model, and it's asking for all three of those things. The variables, the objective function, and the constraints. You don't have to even solve it unless it says solve it. When you formulate or write a linear programming model, you're just creating it. Okay? Showing you can come up. Here we go. This is going to challenge you. I'm going to give you a big hint. There's probably a lot more variables than you think as I first go through this. And there's a ton of constraints. Far more than 5. I think there's maybe like 10 constraints. Are you ready? This company has developed a new instant salad machine. They have a $282,000 marketing budget. Marketing students, I wanted you to identify your, please, any marketing majors. I can help me out here. 1, 2, 3, that's it? There's only 3, and they're all over here. There's no marketing over here. That's it. All right, guys, you ready? Okay, this is reality. This happens at a company. You've been there for a few years. They're handing you your first project. We have this new instant salad machine. We have $282,000. We want you to put together a media blitz. And here's how we want you to do it. You only have Friday, Saturday, and Sunday, and you're about to learn what's available to you to put the media blitz together. And what else? You only have like 3 options. Where are they? The money to be spent on TV advertising during the blitz on Friday, Saturday, Sunday. The 3 options available are daytime advertising. Now, think about this. You have to tell me how many daytime ads you're going to place on Friday.
4.
And how many on Saturday. And how many on Sunday. Evening news advertising on Friday. How many are you going to place on evening news on Saturday? How many are you going to place on Sunday? And then there's Sunday game day advertising. And that's only on Sunday. All right. That's it. It says a mixture of 1-minute TV spots is desired. And you've got to hold the TV executive, whoever, and said, hey, I need to know how much it's going to cost for these ads. We want to do a media blitz Friday, Saturday, Sunday. And can you give us an expectation of the reach during that time on these ads? Well, if you do a daytime ad, any Friday, Saturday, Sunday, you're reaching about 3,000. Is that right? 3,000? And it costs you 5,000. That's really a high cost for such a low reach. That should be more like 30,000. Evening news, you're going to reach about 4,000 for $7,000 each ad. It doesn't matter which day it's on. Okay, keep that in mind. Sunday game, you're reaching 75,000, but it's $100,000. That's what is that? Half your budget almost. Not quite. less than half your budget, all on one ad, but you're reaching how many times the people? This is an instant salad machine. Do not take into consideration who's watching the game on Sunday, because it will just blow the whole thing. So they're not asking you to pinpoint who you're reaching with these ads, obviously. Here's what the company's asking you as the marketing manager who's coming up with the plan. They're saying, will you please do this? At least one ad of each type. Let me say that again. They want you to take out at least one ad of each type. Daytime, evening news, and game time. So you know you're going to be using, but it doesn't say one ad of each type each day. It's just whatever your combination of ads are, at least one of each type. Has anyone figured out, obviously if you went ahead you figured it out, but anybody without the PowerPoint figured out how many different decisions have to be made? Give me at least one decision. What is one of the decisions you have to make?
When you're going to run the ad.
Not when. When, kind of, but give me another way of saying it. What time, that's when. Oh, what type? It's kind of that too. Because the type is the time you're going to put it, but give me more. Give me one variable. Just call the variable, call it, what would be the name of a variable? He's saying the name would be when to place the ad, but that's not the decision necessarily. You're almost there though. The ad time, you're saying that, okay, here's an ad, and you're making the decision what time to place it. What days? What days, but how many different decisions are there to be made, I guess? Let's go with that.
9.
How many?
9.
9. Name 2 at least, 3. Oh, you got it on the PowerPoint? Darn it.
No,
Oh, go ahead, name.
daytime advertise on Friday.
Okay, stop right there. Friday daytime ad. That is a variable because that is your decision. How many of all the ads you're going to place, how many on Friday daytime? That's one of the decisions right there. Tell me that second one.
Daytime on Sunday.
How many ads are you placing on daytime Sunday? Another decision you have to make. How many, we skipped Saturday though, right? How many daytime ads on Saturday? So you have daytime Friday, daytime Saturday, daytime Sunday. There's 3 variables that you have to make decisions on. Keep going. Now that you keep going, what's next? Evening Friday, evening Saturday, evening Sunday. What else? There's game time Sunday. So that's how many variables? 7 variables altogether. 3 because daytime Friday, Saturday, Sunday. 3 evening news Friday, Saturday, Sunday, and then that game time. Those are 7 decisions that you have to make. That's where you would start with your variables. And you have a homework problem that we're going to talk about at the end of class today. And the biggest part of that problem is, and I don't want to see the same variables used on everybody. I know some of you are going to talk and help each other, and that's fine. But I don't want to see everybody using the exact same variables, because that's like, how could that happen? What's the odds of that coincidence? Again, quantum physics, supposed to not be coincidences. There's really no coincidences, but anyway. Also, in your homework, when we get to it, not only are you creating the variables from the story, you're writing the objective function, you're writing the constraints, and then you gotta take the Excel spreadsheet I'm gonna post, or any Excel spreadsheet, and set it all up, and solve it using Solver, save it, email it to me by Tuesday. That's a long way to wait. You'll be fine. It's 5 days. And you can email me if you need help, and you obviously are going to talk to each other and see how everyone's doing.
Well,
I want a separate answer from everybody.
Can we use management scientist for your...
If you rather use management scientist, I'm assuming not everybody knows how to save it. And management scientist is an odd thing, but yes, I'll take it that way too. Everybody okay with that? Do you hear that? I'll take it through management scientist, but this assignment is kind of to encourage you to get more into Excel. You have to. You have to be so aware of how to use Excel to make it through the classes you have ahead of you after this. 2 of them I know for sure, operations and what's the one you have that big simulation in that I brought up a couple times. And in the real world, everybody uses Excel, so you've got to be there. You've got to try to use Excel if you're not an Excel person. And if you are an Excel person and you want to try to use software, that's good practice, because if you go somewhere a company that uses this, it probably won't be the exact software we're using, But I'm trying to get you to see that no matter what the software is, they're all giving you the same information on the output, just different ways. You just got to be so familiar with the information that you can find it no matter which output you're looking at. What else about this? There are 10 daytime spots available. Really? Hang on. There are 2 game time ad spots available. Well, is that a variable? Is that an objective function? A constraint? What is that? Constraint. Limitation. Less than equal, greater than equal. Less than equal, because there's only 2 of those available. So less than equal to 2 is that one. We got to figure out among our 7 variables. Let's start right there. There are only 2 game time ads spots available out of the, what we talked about, 7 variables, right? Out of those 7 variables, how many of them are related to the game time ad? 1. That variable less than equal to 2. That's a constraint by that sentence right here. There are 10 daytime spots. Stop right there. Less than equal, greater than equal.
Less than equal.
Let me read it. Available daily. I've got to make sure I read that day. There are 10 daytime spots available daily, less than equal to 10, but it's each day. So you've got to say, well, what variable represents a daytime spot, on Monday? Or I mean Friday, So you have a variable for daytime Friday. And that one all alone has to be less than equal to 10. Then you have your variable for daytime Saturday, less than equal to 10. Then your daytime variable for Sunday, less than equal to 10. Those are 3 different constraints because of that word right there, daily. It's 10 spots each day, so you got to program that in. How many constraints is that already? Is that 4? The 6 evening spots daily. Take each evening variable. Friday evening, less than equal to, I forgot already, 6. Saturday evening, less than equal to 6. Sunday evening, less than equal to 6. What else? They want you to have, now they're saying at least put 5 ads per day. It doesn't say it has to be all daytime ads, doesn't say it has to be all evening or game time. As long as we look at Friday's combo ads you select, that they add up to 5. So you would take the variable for Friday, daytime ad. Take the variable for Friday, evening ad. And when you add them together, they got to be less than equal, greater than equal to 5. Greater than equal to 5 because it says at least. Management's asking you to plan this media for at least 5 ads each day. Now that's just Friday. Let's do Saturday. The variable for daytime Saturday. The variable for evening Saturday, less than equal or greater than equal to 5. Sunday, you have 3 variables involved. Daytime Sunday, evening Sunday, and Sunday game time when added together needs to be greater than equal to 5. So now we have that first constraint. We have these, well, those 2, that 1 constraint. Then we have 3 more, that's 4. And then we have 5 ads per day. I'm losing count on it. Hey, what was their original budget, by the way?
282.
Less than equal, greater than equal. That's right, you can't go over budget, so it's a less than equal. We got to turn our variables into money. So we will look at, there's our costs. We have to take all 6 variables, daytime Friday times 5,000, daytime Saturday times 5,000, daytime Sunday times 5,000, evening Friday times 7,000, evening Saturday times 7,000, evening Sunday times 7,000, game time Sunday 100,000. All the variables times the amount they cost less than equal to the total budget. There's another constraint. Now look at this one. Spend no more than $50,000 on Friday. You're just grabbing the variables for Friday only. You're making it less than equal or greater than equal 50,000. And you got to take the variables from Friday and turn them into money because they represent how many ads on Friday. Daytime Friday times, help me out, I can't remember, 5,000. Evening Friday times 7,000. When you add them together, have to be less than equal $50,000, right? On Friday, no more than $75,000 spent on Saturday. Daytime Saturday times 5,000 plus however many evening Saturday ads times 7,000, less than equal to 75,000. Is that it? Wait a minute. What's our objective? What's our objective? What is it? What? I don't see it there. What about here? Is there anything here? What do you think we're trying to do? I hear some. Yeah.
Most amount of
Everybody hear
people.
that? Huh?
Most amount of people, minimum amount of
Most amount of people reach. Max or min?
Max.
Max. You got to take each variable, multiply it times the amount of people it's supposed to reach, add them all together, and let it know it's a max. Never use it equal, less than equal, greater than equal in your objective function. We're past that, right? Nobody's going to do that, correct? All right. All right, and here's what it looks like. In this case, here are our 7 variables. Daytime, 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 evening, 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 and the game, just like you said. All right, whoop. Here is our objective function. The number reached, daytime reaches 3,000, evening reaches 4,000, game is 75,000. However many we're going to have of each of these ads times the number they're reaching is what we're trying to max. Get the most bang out of the buck. Here are all those constraints. They asked for at least 1 ad on Friday. So here's all the, at least 1 daytime ad. So here's Friday daytime, Saturday daytime, Sunday daytime, greater than equal to 1. At least 1 day evening ad placed. Evening Friday, Saturday, Sunday, greater than equal to 1. And did it say at least 1 game time ad too? Right. $100,000? Wow. Game time, greater than equal to 1. We're spending $100,000. Management wants it, we're doing it, right? So now we only have 182,000 left. Here it is. There's only 10 daytime spots available. At first you read this, you're going, okay, daytime Friday plus Saturday plus Sunday, less than equal to 10 or less than equal to 30 or something. You have to do them individually. You can't put them together because it's 10 each day. Daytime Friday less than equal to 10. Daytime Saturday less than equal to 10. You can't combine these. Daytime Sunday less than equal to 10. Just like when there's only 6 evenings, you can't combine them. Friday's evening, Saturday evening, Sunday evening, less than equal to 6. Wasn't there a limit on how many game time ads there were? I think there's only 2 of those, but I don't see that constraint. There it is. Game time, only 2 of those. At least 5 ads per day. Here's Friday day and evening, greater than equal to 5. Saturday day and evening. Sunday day and evening plus the game time, greater than equal to 5. Spend no more, how many is that? 13 constraints. Spend no more than $50,000 on Friday. Here's how much we spend on Friday if we go with day. Here's how much we spend on Friday if we go with evening. Can't go over 50,000. Spend no more than 75,000 on Saturday. Here's Saturday's daytime ad cost. Saturday's evening cost, less than equal to 75,000. Is that it? No more than 282,000. Here's the cost related to every one of those 7 variables. Added together, less than equal to. This one we don't need to do anything about this whole semester. This class is all about every variable is going to be either 0 or a positive number, never be negative. We're not going to have -2 daytime Saturday ads. It's possible. All right? Now we solved it. Now, on your homework that's due Tuesday, after you write the objective function and you identify your variables, you write constraints, it's going to say solve it on Excel, and then you got to go back and answer the questions. The questions are about you knowing which variables represent what, because the question is real specific. Like when you're about to see this output, I'm going to say, how many daytime Saturday ads should be scheduled according to the output? And I want to see that you know which variable represents daytime Saturday, and that you're able to answer that question. Something like that. Or let me, I guess, the question, here's another one. With the combination of advertising that's being recommended, is the cost going to be below $250,000? Now, that's all about you knowing where to look to see where that total cost is. Oh, wait. I didn't mean to say cost, because we're not minimizing cost, are we? We're minimizing, or we're maximizing audience, aren't we? Yeah. So it'll be something like, what is going to be the most people we can reach with this combination of ads? And that question is all about you then look at the output, knowing to go to the, say it again, objective function value at the top of the output. That's what you should expect at the bottom of this homework and on your quiz, which has been moved to when? November 1st. You guys sound good happy about it. All right, here we go. How many ads, daytime Saturday, are you going to place? Okay, 5. Very good. But there's a lot of 5s up there. Well, no, there isn't. Okay, just checking. how many people with this combination of advertising are you going to reach? And it's the most people you can reach, no matter if you found an alternative answer that also meets all the criteria. This is the most you can reach, no matter what alternative you go with, which is how many? 199,000. Are we blowing any other money on that Sunday game time other than that first 100,000 that management asked us to spend? Look again. How much are we spending on Sunday's game time ad? How much are we spending?
200,000.
200,000 out of the 282,000. Now, I accidentally blurted out a question I didn't mean to blurt out, but I want to see if you are really understanding this. If you wanted to calculate your total cost for this recommendation, how would you do it? Where would you start? Say it louder. Someone spoke up. Come on. I swear I heard a voice. Or was that from the other dimension? No, I'm sorry. Huh?
EFR?
EFR. He wants to start right here. That's 0.
No. DFR.
DFR, yes, which is at an 8. Then what do you do? Multiply it by the price per daytime ad on Friday. Daytime Saturday, 5 times the price that we're going to be charged for daytime Saturday. 2 times daytime Sunday. 1 times evening Sunday. 2 times $100,000 per ad. That one's easy to calculate. It's just all these other 4. You would just add to it. That's your total cost. You guys start getting familiar enough with these outputs that you can answer any of these questions. There's one more. Is this going to give us the bottom half? Darn. Darn. Wait. Oh, I forgot. Here we go. Is this it? No. Don't even look at that. There we go.
What is that?
Here's the Excel, the same exact thing right here, right? This is all, if we had time to go through, here's 10 per day. There's only 6 evening ads for each evening. Can't remember what these, oh, only spend 50,000 or less on Friday, only spend 75,000 or less. Here's your total budget. So all set up in Excel. What I wanted to show you is, when this gets solved in Excel, I want you to realize you can tell me which constraints are binding. I just don't think we've talked about it yet. And it is here on the output. Okay, let me go back down here. Here's all 16 constraints, left-hand side, right-hand side. Is this a match, right? All right, going all the way over to K, that's correct. Here we go, data, solver, E28, is that correct? It is. E26 through K26, that is correct. These E32, E34 are both greater than equal? 32 through 34, excuse me. 32 through 34, that's perfect. Less than equal on these, greater than equal on these, less than equal on these. These are combined. We talked about this already, how you can combine if they're all the same direction, right? This box is checked right there. Simplex linear programming, hit solve, hit OK. Now this could be an alternative optimal solution, but the number of people we're reaching will be the exact same. No matter if one solution is the same as better another solution, once you see the objective function value, no matter if there's more than one optimal solution, that's the best you can get, even if there were an optimal alternative solution. Is this the same solution as on the output? It's different. So there is more than one optimal solution, but are we reaching the exact same amount of people?
Yes.
Which is 199,000. So, which constraints are binding? Start. Give me at least one. That's not. How about one that's not binding? Give me that. 7? Let me look. Constraint 7 is not binding. She is correct. How did she know that?
8 and 9.
That's right. Because if the left-hand side doesn't equal the right-hand side, it's not binding. It means it has either slack or surplus. And constraint 7 has how much of what slack or surplus?
1.
So, say it again.
1.
No.
That's 5
That's the
slack.
value.
5 slack.
5.
Oh, okay.
Ah. Slack because
Less than.
you said slack too, didn't you? Did you say slack? this output on these Excels, if there's a different number that's being calculated on the left than what the right-hand value is, the difference is slack or surplus. You guys gotta look at here. Right here, slack or surplus. Slack, how much? 6. Slack or surplus? How much?
14.
Big, major. So I want you to be ready, because in your future you're going to have an output, and I'm going to say, you know, which constraints are binding. Like I'll have to go right here, binding. So number 2. Got it. Is that it? Oh, here we go. Number 10, 12, 13, and 16. We have, what was that, 5 binding constraints? You've never seen 5 binding constraints before now. You can see we're getting closer to how it really works in real life. Not just 2 variables, not just 2 lines, you know, and a multitude of binding and non-binding constraints. I want to see how comfortable you are with this output. Which ones, I can't remember them. I gotta refresh my memory. Which ones would have a dual price, the binding or the non-binding constraints, a dual value, if we can see a full output from the software?
Not binding. Binding.
I hear answers. Binding or non-binding? How would we know the answer? What would you, if this were a test question, you didn't know the answer, where would you go to look? What? You can't negotiate on this deal. Not page, but what would you look at? An example what? An example output.
If there's more than one thing happening.
Yeah, you just look at an example output, and if there's a dual price with a binding or non-binding constraint, that would tell you the hint. Because dual prices are either only with binding or they're only with non-binding. And to refresh your memory, look at any output, figure out if the constraint's binding or not, and see if there's a dual price. Nobody's looking, so I guess I will. Here we go. I don't know what page to go to, but because this is something we're about to go over here. Shoot. Someone got an output? Someone got a point? I mean a solid. Here we go. Ready? I'm on page. Share with each other. I'm going to a random page of output. I'm on page 161. It's only a half of an output. Is it, you look at that page and you should be able to answer this question now. And any of these outputs would have given you the answer. Is a dual value with a binding or non-binding constraint? Anybody else? I hear binding, and I hear a lot of silence. If you notice, the ones that have 0 slack surplus on that output are the same ones that have a dual price. The ones that do not have a 0 in the slack or surplus do not have it. So the binding constraints have a dual price. Only the binding. Okay. Let's get to the next one. We're here. You ready? The reason I'm bringing this one up is that I want you to understand there's certain ways things are being described in here, and the hint I'm going to try to teach you right now is when you have one of these, write it out just as it reads. That's the best advice I can give you. That seems to be the easiest way for a lot of people. Write it out the way it reads and then use algebra to fix it. Because when I say use algebra to fix it, don't forget, all of these constraints are not finished until you have all the variables on the left side and only number left on the right side. And if you have nothing left on the right side, if you have nothing left, you can't believe this, I strained a muscle here and my arm won't even go up. So I don't even have my abilities here, I'm throwing things. But I don't even know where I was going with this. What was I saying?
Having all the variables on one
Yeah,
side.
you gotta use algebra. So when you write this out, if they're not all on one side, you're not done. Get it over the left side. Here we go. This is marketing again, media, same thing, but just a little differently. Westchester Chamber periodically sponsors the public service seminars and programs. Currently, promotional plans are underway for this year's program. Advertising alternatives include television, radio, newspaper. Think about what decisions have to be made. Let's see if there's multiple days involved. Audience estimates, cost, and maximum media usage. If this were on a quiz, so I know that people start raising their hand, like, what is this type of thing? But it's let's call it a score, like an index score maybe. And let's assume, since it's called maximum media usage, let's assume the higher the better. And then here they are. So, here are television, radio, newspaper. Here's their audience, here's their cost, and here's their little, we'll call it like an index number called maximum media usage. Now, my question for you is, how many decisions do you think you have to make? Maybe I'll read a little more. Just now, we're starting to writing things right now. How many variables or decisions do you think would have to be made if this were a real assignment? 6. I heard 6. 9. I heard 9. Any more? Any less? 3. Who is 3? I like 3. I don't see the other dates. All I see right here is that how many of these television, how many radio, and how many newspaper. Now, if this problem said is how many television you want on this day and how many on that day, those are 2 separate variables, even though they're both television. But I don't see where there's different days in this so far, so I'm going with 3 to start with, and I'm going to just go with T, R, and M. Is that M? M. All right? So, if this were a problem on homework, you would tell what T is, R, and N. You would tell me what they are. And just don't write television ads. The number of television ads. It's how many television ads. That's really what the decision is that variable represents. Are you ready? To ensure a balanced use of advertising media, this is it. Here's your beginning right here. Everybody read the book, by the way. It's on page 189, problem number 1 at the end of your chapter 4. I just have an older edition here that I found on PDF. You ready? Here's your first one where I want you to write it as it reads. This is the easiest way to do it. To ensure a balanced use of advertising media, radio advertisements must not exceed, just write it, I'm going to 50% of the total number of advertisements authorized. Let's go just the way it reads. The first word says, radio advertisements. What variable represents radio advertisements? R. Then it says, must not exceed, less than equal, or greater than equal, or equal. There we go, just like it reads. 50% of the total number of ads. 50% of total number of ads. 0.5. And you were saying, oh, I heard. 0.5 times what? There you go. T plus R plus N, it would represent all the N's. Radio must not exceed 50% of all the ads that are going to be offered. That's exactly the sentence, and I wrote it exactly. Now you go, okay, now I got to apply algebra. This is not finished. I like to take the 50% times each variable and spread it out. So I go R less than equal to 0.5T plus 0.5R plus 0.5N. Now I got to get all those variables to the other side. They're all positive, so I'm subtracting. But, so I'm going to subtract, I'm going to keep them in the order, just to make this easy, I guess. 0.5T, subtracting from both sides, gives me a negative 0.5T. Now I've got, subtract a 0.5R, but I've got a full R here. Yep. So if I subtract on both sides, what do I have left? Positive 0.5R is what's left, you're right. And then, no N's, but I'm subtracting, uh-oh, where's my 0.5? I left it off. 0.5N, so minus 0.5N, less than equal to what? 0. Because there's nothing left on the right. And now you have nothing but a number, and that's ready to be entered in the software, or Excel, or ready to be solved.
Can you
Right.
subtract the R instead, so you have to subtract all those?
No. You have one full positive one here. When we subtracted the half on both sides, that still left a positive half.
I mean, because the R is over there, instead of subtracting all those, just subtract the R from this side and give it 0 on the
If
left.
you, well, if you do that, I think you have to change the direction of the sign. I'm trying to remember here. How this, so, hang on a minute, let me see.
It's definitely divide by negative, isn't it?
So what you would have left then is 0 less than equal to 0.5T. He's saying make this a minus 0.5R, because he's subtracting a full R from this one, plus 0.5N. Let me just look at this. All of the signs are the backwards of this one. This is at a less than, but now they're greater than, so that would work. They're both saying the same thing, actually.
Yep.
Yep. Now, when you enter it, you got to enter this side first. This time, but you're making it a less than. Because this is positive, negative, positive, it's okay. By the way, whenever you divide like by a negative number, doesn't the sign change? Anybody? Is that an old rule from algebra? Anytime you divide both sides by a negative number, you've got to flip the sign.
Yeah.
And that's kind of what is happening here, but we're not dividing, we're just placing them on the other side in their opposite. Entangled particles? Do we want to go to entangled particles at all? No? You sure it's like, everybody got that? All right, making sure. All right, next sentence. In addition, television should account for at least 10% of the total number of ads authorized. Write it just like it reads. Let me read it again. In addition,
Hey.
television,
T.
T, should, I gotta read it again, should account for at least greater than equal to 10%, 0.10
Times everything.
of times all the ads authorized, just like up there, T plus R plus N. Again, same thing. Multiply those by 0.1 to get rid of the parentheses, and then subtract or add, whichever direction you want to go. I bring the variables to the left because then I have it right there the way I enter it. So I'm just going to do it that way, but feel free to do it the other way. I have no problem with that. T greater than equal to 0.1 T plus 0.1 R plus 0.1 N. I'm going to subtract 0.1 from both sides, right? So I'll start with the T. I got a full one. I'm subtracting 0.1, so I'm going to have 0.9 positive 0.9 T, right? And then I'm taking minus 0.1 R on both sides, minus 0.1 N on both sides, greater than equal to, and all that's left is 0. So there's two of them. Next it says, if the promotion budget's limited to $18,200, how many commercial messages should be run on each medium? Television, radio, newspaper. Let's just stop right there. To maximize total audience contact. Key sentence. Let's stop there though. Let's write an objective function based on that and we'll go back to the money. Objective function, max or min? Max. So we got to turn these variables into what it's referring to, which is audience reached, correct? So what do I put with the T?
100,000.
100,000 T plus what goes with how many? 18,000 R plus 40,000 N. There's what we're maxing. Now the money. How much again? 18,200. Less than equal or greater than equal 18,200? Less than equal, we never go over budget. We either spend budget or less. And I very rarely have ever met a marketing department head that spends less than budget. They'll spend every penny and then come ask for more. I just bring that out so the marketing majors will go, I'm going to be different. I'm not going to make the accounting people mad by spending every penny every single time. You get asked for the other
That way
night.
they lower your budget.
I'm sorry?
So you have to, huh? They'll lower your budget next time.
Yeah, that philosophy's off. Instead, if you don't spend it all, I'll take half of it for back to the company, and the other half I'll put it as your Christmas bonus. How's that? Does that encourage marketing to not spend it all then maybe? Don't get me wrong. I'm just saying. I'm just trying to be the person of common sense at the table. All right. A, let's do this. How do I turn the variables into $18,200? T, N, R, N. I got to turn them into money. So what do I put with the T?
2,000.
2,000 T plus, how much do we spend for every radio ad?
300.
300 R plus the newspaper.
600.
600 N. The newspaper ad is more expensive than the radio because we're reaching such a larger audience, I guess. There's that constraint. Then it says, what is the allocation of the budget among the three media? Wow. If you were looking at the output and you saw that question, what is the budget allocation? They're saying out of all the money that's going to be spent, how much of it's going to be spent on television, how much is going to be spent on radio, how much on newspaper, how would you calculate that?
Is it like one for each?
Well, not one for each, but is that what you said?
Like, I don't know.
Did you say one for each?
Kinda.
You would look up how many the optimal solution says you're going to have in television ads. So let's say it says 3 television ads. Then multiply it times the price for television ads, and that's the amount of budget that's gonna be spent on television ads. Look for the optimal value for radio ads. How many, let's say it says 5. Then multiply that times the cost of every radio ad, and there's the amount of money that's gonna be spent on that. And same with newspaper. So that's how you attack it. Just, you gotta find that optimal solution. Did I solve this one? That's the question. No, I didn't. So we don't have it. What's B? Okay, B. How much, by how much would the audience contact increase if an extra $100 were allocated to the promotional budget? What's happening when you are told a sentence, add $100 to the promotional budget? Is that a, think about it, going back to chapter 3. What's happening there? Put in the words from chapter 3. What's happening? Is,
Range of feasibility.
it's the range of feasibility taking place. If you're increasing the budget $100, that's talking about the right-hand side of a constraint, but now it's in words. It's not gonna, this question is not going to say anymore, the right-hand side of constraint 2 is going up $100. It's going to be words like this. You've been told we have an extra $100 for the marketing budget for this promotion. You know, how is that going to affect things? What's your first step with that $100? To look at what?
Look if it's in the limits.
I heard it. Say it again.
Look if it's in the limits.
See if it's within the upper limit. It's going up $100. What's the upper limit? Number 1. Is this a simultaneous change? Do we need to do a 100% rule? No. That's right. Then, let's say it is within the limit. What are you now doing with that $100? And the dual price happens to be a positive number. Do we multiply or add it to the 100? No. Not yet. The next step, maybe. We multiply it times the dual price. Then we look at the objective function value. We know it's what kind of a problem, max or min.
Max.
Now we do what?
Yeah.
Exactly. Because we realize the max, a positive effect would be going up, which would be adding to it. The 100 times whatever the dual price is. So that's what's happening right here, but now it's in words. In words that you got to say, oh, that's a right-hand side. They're asking if it goes up $100. It's right here. That's going to go to 18.3. Your first reaction is to go, I'm just going to solve this, put 18.3 in, let's see. But this question is really, and I'll probably put some additional words if I had a question like this, is trying to get you to do an analysis of the output by looking at the upper limit, looking at the dual price, calculating the new objective function value. And the new objective function value here, because the objective function is maximizing the audience reach, that's what these words mean. Audience contact increase is how much will the objective function value go up because of this right-hand side of this constraint going up $100 by just analyzing the output. Okay? You guys, you look like you've been beaten already. We've got 2 more to go. I hope you're going to make it. You ready? We're going to blending. I think this one's a little easier in my opinion, but they're all not easy. You ready? The trick to this one is that everything you see in the next slide is going to be in pounds per pound. Don't change it just because we're making half-pound or 8-ounce packages of the dog food. Okay? That's my hint as we get started. Don't go and change all the numbers. Just realize everything's per pound, but we're making half-pound bags. And we'll fix that in the constraint or the objective function or something to realize we're only making half-pound. Don't change the numbers. You ready? You're an entrepreneur. We're going now to the entrepreneurs in this room. And you've got a job, and you work from 8 to 5, I don't know, 9 to 5 means 8 to 5, and plus you always work a couple extra hours because you're doing your job, and you want that promotion, and extra pay, and you're trying to prove yourself. But when you get home, you got a little side business going, just in case, you know, in case you decide you want to quit your job someday. You got it going in your garage or basement. And what happened was on Craigslist, down in Cleveland, somebody was selling these containers that you set, and it dumps the exact amount of a raw material into something. And you bought 3 of them, maybe 4, I gotta remember. 3 of them. And you want to do your own dog food. And so, in doing so, you said, you know, if this took off, I could quit my job, have my own business, but this is the way it my opinion, you start a business on the side, you have the security of your real job. You do it at night, in the basement, in the garage, if it's something that's a really good idea, and you see, and if it is a good idea, you'll know it when you get out there and start with this product, and you'll know then if you need to commit a bunch of money in a bunch of time. But to start with, you spend as little money as you can to see if this idea will float or not. In this case, you're thinking about some pet food, I think it's dog food, some pet food, you want to make your own, you think you can make it better and less expensive and beat the prices and still have a great margin and make some money. It's an 8-ounce packet, which is a half a pound. But you contact the government and they said, hey, even though it's pet food, you have minimum requirements you have to meet in vitamin C, protein, and iron. And then you're going to use some raw grain, and each of these grains, these 3 different grains you have vitamin C, protein, and iron. It just seems like the lesser expensive grain has less of these things, and the more expensive grain has more of this stuff. You're trying to figure out what combination of these grains will keep your cost as low as possible while making sure you meet every requirement the government is putting upon you for each packet. Here, if you go with grain, I'm sorry, there's 4 grains. We got 4 of these machines. There's 4 of them. They came in a 4-pack. It's like an assembly line. And as the 8-ounce bag goes by, the indicator realizes there, dumps exactly what you set it at. SPC, statistical process control, where are you? No one. All right. Second one, set right to the right amount. It dumps in, dumps in, dumps in, and then it goes, gets sealed by somebody, tagged, whatever, just put it in the box, and it's ready to go out the door. You're trying to decide what combination should be going in each bag to make sure and meet the government's minimum quantity of units in each bag of vitamin C, protein, and iron. While at the same time, whatever that combination you're putting into that bag is supposed to keep the cost as low as possible. Meet the requirements, keep the cost as low as possible, so you can keep the margin, gross margin of profit before overhead as big as possible. The margin as big as you can. You ready? How many decisions do you have to make?
4.
4. How much of each grain is going to go into a bag? What are you setting that little dial at the end of that big thing with the grain in it to dump into the bag? What are you setting that at? That's what your decision is. And grain 2, what are you setting that one at? Because it's what you set those at that will allow the 8 ounces to go in at the perfect combination to keep your cost as low as possible and still meet those requirements. Let's start with, what are we going to start with here? There's, we'll call it X1, 2, 3, and 4, okay? One time I got a flu shot, a long time ago, many years ago, and they put it right into the muscle. Has anybody ever had that happen before? Mm-hmm. And it hurt for like a week. Anybody know what I'm talking about? It was like really pain at first. I don't know what's going on, but when I was sleeping, somebody gave me a shot right in my muscle. And I'm on the 5th day of this. So I don't know how it happened. Again, the other dimension. All right. However much, I haven't seen this in so long, I'm trying to remember here. Let's start with what is our objective function? Oh, I'm sorry, here's the variables. X1, X2, X3, X4, the numbers represent the grain that's going to be used. And this is all about what we're setting those little dials at is how much grain is going to be put into each one. And it's of a pound. Like one could be 0.5, meaning a half, well it can't be because the whole bag's a half a pound. Right? Because all of that's in pounds up there, and we're only putting together an 8 ounce bag, which is a half a pound. However much of grain 1 we're using, plus however much of grain 2, plus however much of grain 3, plus however much of grain 4, here's one of those rare equals. But this could be like greater than equal, but we're trying to stay on exactly at the lowest cost possible. And this is going to be a half a pound, and that's how you fix the whole point that it's an 8 ounce bag. But as students in the past say, you got to change, double all these numbers. Because it's, or split all these numbers in half because it's an 8-ounce bag and these are all in pounds. This already takes it to a half-a-pound bag. The exact amount, the optimal solution will be is how much you're putting in of each grain into a half-a-pound. So it will tell you exactly the mix for 8 ounces, which is a half-a-pound. Now, are you ready? Let's talk about this sentence. The 8-ounce mixture has to have is at a minimum cost. Let's go with that now. Objective function, max or min? Min. I got to turn the variables into money. X1, what do I do with that? Yeah, 75 cents times whatever percent of a half-a-pound or whatever amount we're putting in for X1, plus 90 cents times X2, plus 80 cents times X3, plus 70 cents times X4. Minimize that cost. These variables will represent exactly how much of a half-a-pound's going in times their prices. Per pound, doesn't matter. Okay? Next, says daily requirement is 6 units of vitamin C per bag. Less than equal to, greater than equal to 6 units. Greater than equal to 6. Now, what is it? How do I turn these variables into vitamin C? X1, you're saying is a 9? That's right. There'll be, if we put a whole pound of X1 in, there'll be 9 units of vitamin C. But we're not. This X1 is going to represent that small amount we are putting in times 9 units. It's going to be a percent of that, a very small amount of 9 units. How many would we get out of 2? 16? 16 times X2 plus 8 times X3 plus 10 times X4. Cheyenne, are you ready? You do not look ready. I'll keep going. 5 units of protein. Less than equal, greater than equal to 5. Thank you. Turn the variables, have it represent protein. X1, what do I put? There you go, you guys are getting this. Plus 10 X2 plus 10 X3 plus, what's the last one? 8 X4. Then it says 5 units, well that's protein, 5 units of iron. Less than equal, greater than equal. Greater than equal to 5. But I got to turn the variables into protein. Is that protein? Iron, excuse me. So what's the first one? 0. There's no X1 has no iron. I'm leaving it off. I don't even need to put a 0. X2, 14 X2 plus 15 X3 plus 7 X4. You're looking at this from a financial investment point of view. My question for you is, you hope which grain is the most of the combination because if your number one worry is money.
X4.
That's right, X4 because it's the least expensive. You're hoping that, but you know you got minimum requirements that you are for sure going to meet. Good. All right, you're done. You got to talk about your homework. And just enough time to make sure you understand this homework. So we will pick up right where we left off. We're going an extra day on this chapter, purposely. That's why the whole quiz is moving. I knew we wouldn't get through it. So we're going to have 3 lectures on chapter 4 instead of only 2. And then that's why the quiz is moving up. This homework, for you to understand it, is why we left just this exact amount of time to talk about it. So you are not just going nuts over the weekend. You ready? It looks hard at first. I'm going to break it down for you. O'Grady Industry manufactures several lines of decorative and functional metal items. The most recent order has been placed for 1,260 door lock units. Now I want to make sure you understand there's 3 components to this door lock unit. There's the knob and plate, the lock, and then a set of keys. Every one of these gets 1 set of keys. This is for a set. You guys with me? Treat it as 1. Even though it's 2 keys, treat it as 1 because 2 keys are going with that and that. When these are being manufactured, they all use some brass, machining, and finishing time. And here's our limitation in each of those 3 departments, or those 3 resources. And we realize as a company that for us to fill that order of 1,260 right now, with those resources that we have, we cannot meet this order. But we're not gonna lose it, because they've offered us how much money? If we can supply them with all 1,460, we will get how much? $28,000. This contract's for $28,000. And I want to know if we should take this contract. Okay, you ready? So what we did is we got a hold of a subcontractor that does exactly what we do. And we said, if we were to make as many as we can and subcontract out the rest, will this higher cost, because we have someone else making it, eat into our profit to the point to where we should never take this contract? All right. Are you starting to think about what decisions have to be made? How many decisions do you see at first glance? 3 would be if we could make them all.
That's 9.
But say it again.
9.
I don't know if there's 9.
6.
I see 6. Decision is, you're figuring out how many knob and plates we're going to make, we're going to schedule for production. How many lots we're going to schedule for production, and how many sets of 2 keys we're scheduling production. And once you know that, you then got to decide how many knob and plates you're ordering through the subcontractor. You're taking down your specs, and you're saying, while we're making ours, we need you to make yours. How many you're going to have them making lots, and how many sets of 2 keys they're making. Look at how much we're paying for each of these items to have someone else make them instead of ourselves. You know, so you gotta, obviously we want to make as many as we can, but if we, you know, if this eats up into our profit to the point to where this contract of $28,000 is not going to make any money for us, then it's not worth it. But if this is eating up some of the profits, and we're still able to make enough that we're going to make a profit off it, and if the profit's significant enough, we're probably going to want to go forward with this. That's what the last question on this, when you go through the questions, is letting me know why you're saying yes or no to go with this $28,000 contract. Explain why. Okay? Plus, I'm going to keep reading here. So you have your limitations. You just talked about having a certain amount of variables that just to help you out. I think you talk to each other. And then it says, develop a linear programming model that would tell O'Grady's how to fill this order of the 1,260 lot sets at a minimum cost. Objective function, max or min. And you got to turn all 6 variables into money, and you're probably using this area right here, right? Whatever variable you're using for the amount we're going to make of knob and plates times $5. However many knob and plates we're getting from the subcontractors times $9. $4 and 7, make them or buy them from the subcontractor. $1 or $2 if we make them this set of keys, or have them make the set of keys. Obviously, the goal here is that we hope this comes up with us making as much as we can, and then we evaluate how much it's going to cost us, you know, to order from the subcontractor that's eating in the profit, and see if there's still enough profit to make this job worth it or not. In most cases, in real life, I've always found that even if you're using a subcontractor, you don't want to let that contract go. If you have the opportunity to get that $28,000 revenue, even with these higher costs, it's usually a rarity that this will eat up to the into the profit enough that you change your decision. And I hope that's not the case here. Let me look at the next question. You ready? I thought to myself, develop a linear programming model. I don't know if we talked enough about what that meant, so I put, it means identify the variables. It means write the objective function and write the constraint. That's what develop a linear programming model means. Now, left you a lot of room for that. Now, solve this problem using Excel. This is the time. There's a couple of spreadsheets already posted. I'll post another spreadsheet that we saw. You can change it any way you want, get rid of rows, or add a column, or add rows. But I wouldn't change the formulas. You just either need to add a variable or take away a variable from the formula so they're already there. Because I already did this using one of the spreadsheets we saw today, and I realized there's really not a lot of work in the formula area other than just maybe taking away a variable depending on which spreadsheet you're using. And then you go to page whatever and follow the instructions. You go to data, you go to solver. You know, use lab anywhere if you don't have solver on Excel at home or whatever. And then you're going to put in the location where the objective function is being calculated, the location where the optimal solutions are, and so on. Then, answer these questions from your output, your Excel output. How many knob plate units should be bought from the subcontractor? You're going to look at the variables, optimal solution, and one of those variables are going to represent knob plate. Not the lock, not the keys, the knob plate. And that variable is going to represent how many you're buying, not how many you're making. And that's what the question is. This is all about you recognizing where on the output the answer to this is. This one says, how many key sets will they make themselves? What other variable represents the key sets we're making and not buying from the subcontractor? This says, if an operating industry is going to receive $28,000 revenue for the order, will this cover their total minimal cost for making and buying all these components together? Now, is the objective function already in the realm of money and cost? I can't remember. It is. So where would you look then to figure out if 28,000 is going to get us a profit on the output? Where would you look? The objective function. Wow. Okay, you talked enough. That's way too many hits. Way farther than I expected. My suggestion is attack this while it's fresh in your mind tonight. You don't have to finish it, but at least attack it while it's fresh in your mind, because if you wait till Monday or Tuesday, you're going to forget all of it. Or at least half of it, and it's going to make it a lot harder. Because it's, you know, it's not hard, but it's going to be your biggest challenge you have yet, I think, don't you think? There's several constraints involved. All right, good luck. I'll see you guys. Oh, wait, God. We didn't get, I changed and didn't have any class time. I got to take attendance real quick. Okay, sorry. All right. Just making sure.